Today is going to be one of the more difficult lectures of the term, so put on your thinking caps, as they say in elementary school. The topic is going to be what's called the convolution. The convolution is something very peculiar that you do to two functions to get a third function. It has its own special symbol, f of t. Asterisk is the universal symbol that's used for that. So this is a new function of t, which bears very little resemblance to the ones f of t that you started with. I'm going to give you the formula for it, but there are two ways of motivating it, and both are important. There's a formal motivation, which is why it's tucked into this section on Laplace transform. And the formal motivation is the following. Suppose we start with a Laplace transform of those two functions. Now, the most natural question to ask is, since Laplace transforms are really a pain to calculate, is from old Laplace transforms, is it easy to get new ones? And the first thing, of course, summing functions is easy. That gives you the sum of the transforms. But a more natural question would be, suppose I want to multiply f of t and g of t. Is there hopefully, some neat formula? If I multiply take the product of these two, is there some neat formula for the Laplace transform of that product? That would simplify life greatly. And the answer is, there is no such formula, and there never will be. Well, we will not give up entirely. Suppose we ask the other question. Suppose instead I multiply the Laplace transforms. Could that be related to something I cook up out of f of t and g of t? Could it be the transform of something I cook up out of f of t and g of t? And that's what the convolution is for. The answer is that f of s times g of s turns out to be the Laplace transform of the convolution. The convolution, and that's one way of defining it, is the thing that the function of t that you should put in there in order that its Laplace transform turn out to be the product of f of s times g of s. Now, I'll give you in a moment the formula for it, but I think I'll give you 1¼ minutes, 2 minutes, of motivation as to why there should be such a formula. Now, I won't calculate this out to the end because I don't have time, but here's the reason why there should be such a formula, and you might suspect, and therefore it will be worth looking for. It's because, remember I told you where the Laplace transform came from, that the Laplace transform was the continuous analog of a power series. So that when you ask a general question like that, the place to look for is if you know an analogous idea, say, does it work, something like that work there? So here I have a power series, summation an x to the n. Remember, you can write this in computer notation as a of n to make it look like f of n, f of t. And the analog is between n is turned into t when you turn a power series into the Laplace transform, and x gets turned into e to the negative s, and one formula just turns into the other. Okay, so there's a formula for f of x. This is the analog of the Laplace transform. And similarly, g of x here is summation bn x to the n. Now, again, the naive question would be, well, suppose I multiply the two corresponding coefficients together and add up that power series, summation an bn times x to the n. Is that somehow, or it's some related to f and g? And of course, everybody knows the answer to that is no. Has no relation whatever. But suppose instead I multiply these two guys. Well, in that case, I'll get a new power series. I don't know what its coefficients are, but let's write them down. Let's just call them CNs. So what I'm asking is, if this corresponds to the product of the two Laplace transforms, and what I want to know is is there a formula which says that Cn is equal to something that can be calculated out of the AI and the Bj? Now, the answer to that is yes, there is. And the formula for Cn is called the convolution. Now, you could figure out this formula yourself. You figure it out. Anyone who's smart enough to be interested in the question in the first place is smart enough to figure out what that formula is. And it will give you great pleasure to see that it's just like the formula for the convolution that I'm going to give you now.